Hello class, we're about to start section 7.2, linear functions and their graphs. Objectives: use intercepts to graph a linear equation, calculate the slope, use the slope and y-intercept to graph a line, graph horizontal and vertical lines, interpret slope as a rate of change, use slope and y-intercept to model data. Graphing using intercepts. In this section, we will learn about linear functions and their graphs. A function whose graph is a straight line is called a linear function. All equations of the form ax plus by equals c are straight lines when graphed, as long as a and b are not both zero. Equations in this form are called linear equations in two variables. We can easily graph equations in this form by finding where the graph intersects the x-axis and the y-axis. An intercept is a point where a function crosses the x or y-axis. The x-coordinate of the point where the graph intersects the x-axis is called the x-intercept. The y-coordinate of the point where the graph intersects the y-axis is called the y-intercept. To graph a line using intercepts, find the points where the line crosses the x and the y-axis. Locating intercepts. To locate the x-intercept, set y equals 0 and solve the equation for x. To locate the y-intercept, set x equals 0 and solve the equation for y. An equation of the form ax plus by equals c can be graphed by finding the x and y intercepts, plotting the intercepts, and drawing a straight line through these points. When graphing using intercepts, it is a good idea to use a third point, a checkpoint, before drawing the line. Now, we need to scroll down to the next page. It says using intercepts to graph a linear equation. Graph the linear equation in two variables, 3x plus 2y equals 6, by finding the x and y intercepts. Number 1, find the x-intercept by letting y equal 0 and solving for x. So let's do that now. We have 3x plus 2y equals 6. Now to find the x-intercept, we're going to let y equal 0. So it'd be 3x times 2 times 0 is equal to 6. Now we know this will be 3x, and 3x plus 2 times 0 is 0, so it still would just be 3x, and that equals 6. We divide each side by 3, and we will have x is equal to 2. Now typically we will write our x-intercept as an ordered pair. So it'll be 2, 0 will be your final answer. Okay, now we want to look down here at number 2. It says find the y-intercept by letting x equal 0 and solve for y. So we will still have the same equation, but this time we're going to substitute in 0 for x and solve for y. So we have 3 times 0 plus 2y equals 6. 3 times 0 is 0, plus 2y is 2y, and that equals 6. We divide each side by 2, and y is equal to 3. So we'll write this as an ordered pair, which would be 0, 3, and that will be your y-intercept. Now we go here to number 3. It says find the third point, a checkpoint, by letting x equals 1. So we would take this same equation, but this time we will substitute in 1 for x. Now 3 times 1 is 3, plus 2y equals 6. We will subtract 3 on both sides, and 2y is equal to 3, and we'll divide each side by 2, and y is equal to 3 halves. Now we will write this as an ordered pair. Remember, 1 was our x, and 3 halves is our y. So this will be our ordered pair. Now, it says graph the 3 points on the given graph. Draw the line passing through the 3 points. Okay, now first of all, we know, going back up here, that our x-intercept is 2, 0. So we will plot 2, 0. We'll go to the origin, move 2 to the right, And since y is 0, that'll be our point, 2, 0. Now we would do the y-intercept. The y-intercept is 0, 3. We go to the origin, and we would just go up 3 because our x is 0, so we don't move on the x-axis. Now for the third point was 1 and 3 halves. So we'll go to the origin, go over 1, and 3 halves is the same as 1 and a half. So now we need to connect these points. Now I took the liberty of connecting these points here, as you all can see, and this is our final graph. Now we scroll down here. It says using intercepts to graph a linear equation. Graph the linear equation in two variables. 5x minus 3y equals 15 by finding the x and y intercepts. Now to make this a little easier, I'm going to go 1, 3, and then we will do 2 and 4 at the bottom. So with number 1, we have the equation 5x minus 3y is equal to 15. Now we want to find the x-intercept, so y would be 0. So we'll substitute in 0 for y. So we will have 5x, and we know minus 3 times 0 is 0. So that still will leave us 5x equals 15. We'll divide each side by 5, and x is 3. So our ordered pair here would be 3, 0. Now let's look at number 3. It says find the third point, a checkpoint, by letting x equal 6. So we would take this equation and substitute in 6 for x. 5 times 6 is 30, minus 3y equals 15. Subtract 30 on both sides, because remember we're trying to get y by itself. So we have negative 3y equals negative 15. Divide each side by negative 3, and y is equal to 5. So our ordered pair here will be 6, because x is 6 and y is 5. So now we go down here to number 2. It says find the y-intercept by letting x equal 0. So now we have to use the same equation. It's 5x minus 3y equals 15. But this time we're going to set the x equal to 0. So we have 5 times 0 minus 3y equals 15. We know 5 times 0 is 0. 0 minus 3y is a negative 3y equals 15. Divide each side by negative 3, and y is equal to negative 5. So our ordered pair here will be 0, negative 5. Now we have our 3 ordered pairs. Now we want to graph this. So first thing we would do is go to the origin. And we know that our x-intercept was 3, 0. So we'll go to the right 3, plot our point here. Now with our y-intercept, we have 0, negative 5. We go to the origin and plot 0, negative 5. So we know we don't move on the x-axis, but we go down 5. Now, we have one more point, which is 6, 5. So we'll go to the origin, we'll go to the right 6, and we'll go up 5 and plot our point. Now we have to graph this. So I took the liberty of graphing this here, as you all can see. And remember, when you graph these linear equations, you must have the arrowheads to signify that they go on forever. Now, we scroll to the next problem. It's basically the same directions, but we have the equation x minus 3y equals negative 6, and we want y to be 0. So it'll be x minus 3 times 0 is 0, x minus 0 is x, equals negative 6. So our ordered pair would be negative 6, 0. Now we come here, we will have x minus 3y is equal to negative 6. And this time we want to substitute in 3 for y. So we will have x minus 9 equals negative 6. Now we will add 9 to both sides. and x equals 3. So our final answer here would be 3, 3. Now we come here using the same equation. X minus 3y equals negative 6. But this time we're going to find the y-intercept. So we'll make x 0. 0 minus a negative 3y is negative 3y. And it equals negative 6. We divide each side by negative 3. And we know that will give us y equals 2. And so our ordered pair would be 0, 2. Now we want to graph this. Our x-intercept was negative 6, 0. So we start at the origin and go 6 to the left. Plot our point. Our y-intercept is 0, 2. Start at the origin, and then we will go up 2. And finally, our other ordered pair is 3, 3. Our checkpoint. So we'll start at the origin, go to the right 3, and go up 3. Now we have to draw our line. And as you see, I took the liberty of drawing this line here. Okay, so now we need to scroll to the next problem. Now it's basically the same directions as before, but we have a new equation. We have 4x plus 2y equals 4. And we'll substitute in 0 for y to find our x-intercept. So we will have 4x because 2 times 0 is 0, and 4x plus 0 is 4x equals 4. We'll divide each side by 4, and x is 1. So our ordered pair would be 1, 0. Now we go here. We have 4x plus 2y equals 4. We substitute in 2 for x. 4 times 2 is 8 plus 2y is equal to 4. Subtract 8 on both sides, and 2y equals negative 4. Divide each side by 2, and y is negative 2. So our ordered pair would be 2, negative 2. Now we come down here to the bottom. Now we're going to try and find the y-intercept here. So we'll take the same equation, but this time x will be 0. Four times 0 is 0 plus 2y is 2y. That equals 4. Divide each side by 2, and y is 2. And the ordered pair is 0, 2. So now we graph. Our x-intercept we know is 1, 0, so we'll go to the origin, go to the right 1, plot our point. Now the y-intercept is 0, 2. Stay at the origin, but we go up 2. And finally, our checkpoint ordered pair is 2, negative 2. So again, we start at the origin, we go to the right 2, and then we go down 2. And now we need to draw our line. And as you see, I took the liberty of drawing this line here. Now, we go to the next page. We have slope. Slope is a measure of the steepness of a line. It is the same as the measure of the steepness of a hill. For example, a 6% grade means that there is a vertical change of 6 feet for every 100 feet of horizontal movement. Slope compares the vertical change, the rise, to the horizontal change, the run, when moving from one fixed point to another along the line. The slope of a line is the ratio of the rise to the run. In other words, slope measures the ratio of the change in y to the change in x. Now the definition of slope. We have this definition here which we just read off, and we also have the slope formula here. And this is also a slope formula. And we also show where you could do it on a graph. You could do rise over run on a graph as well. Now, reading the next few bullet points.